Hey Sam, this is Dan with Apex Tutoring, and we wanted to help you out with this question you had in the topic of finite math on the simplex method. The question you asked us about is that a man would like to maximize the number of calories burned in a new exercise program. And in this program, he can burn 200 calories per hour while bicycling, 516 per hour jogging, and 274 per hour swimming. He'd like to exercise at most 26 hours, with 4 of those being swimming, and to jog for no more than the total number of hours bicycling and swimming combined. We want to find how many hours we want to use to maximize the calories burned, and we want to figure out how many pounds he'll lose per month if 3,500 calories burned will cause him to lose 1 pound. Okay. So let's get this set up. We're going to use the simplex method for this. It turns out to be one of the easier ways to set these up. It converges on a solution pretty quickly, and it only takes a couple of steps. So we're not going to talk a lot about the theory behind the simplex method, just how to use it. But the idea is that when you have a system of equations with several variables, and you have constraints that could be inequalities, what you're really looking at is finding the maximum value of a function that has several variables. And if you think about a function of 2 variables, then you get something like y equals x, or maybe y is less than x. And that gives you, just for 2 variables, a 2-dimensional function. But if we have 3, 4, 5 variables, very quickly you're getting into higher dimensions. It's very hard to graph. So the simplex method, which was invented in the 40s or 50s, 1940s or so, quickly converges on a solution. So first of all, we're going to set this up. We're going to say that the variable x1 will be the amount of hours we spend bicycling. We're going to say that x2 is the number of hours we spend jogging. And we're going to say that x3 is the number of hours we spend swimming. Okay, and what we want to do is we want to maximize the number of calories burned, and we're going to represent that with the variable z, and that's going to be 200 calories per hour times the number of hours bicycling, plus 516 for jogging per hour, plus 274 per hour while swimming. That's our first step, and we're going to have several constraints. Our constraints are going to be the following. First of all, our total number of hours exercising per month is not to exceed 26. So that's less than or equal to. Secondly, we don't want to swim any more than 4 hours. Finally, we want to make sure that the total number of hours jogging is less than or equal to the hours bicycling plus swimming. Now, the reason I wrote it here is that we're going to write this in a standard form so that we have x1 being negative here, plus x2 minus x3, and of course that will be less than or equal to 0. Okay, so this is what we want to do. We want to set up a tableau that shows all of these values, and we're going to systematically work to maximize the number of calories, or the output. So let's set that up. So our first step when we set this up is to write the initial tableau. And so we want to label this with our variables. And we're going to have to introduce 3 slack variables, S1, S2, and S3. And what these do is these allow us to have inequalities. So we'll start it like this, and we'll start with our initial knowledge that the total number of hours must be less than or equal to 26. But we'll put a 1 here for our first slack variable. because x1 plus x2 plus x3 don't have to add up to 26. These other variables will be 0. Our second one, the one stipulating that we have 4 hours maximum of swimming, will look like this with a second slack variable. And these z's are 0 because that is the so-called profit or cost function which we're trying to maximize. And in this case, it's the number of calories that we're trying to maximize. The third is going to be our constraint that biking and swimming must add up to the number of hours jogging. And then finally, we'll put in our numbers here. For our cost maximizing function, or to maximize our calories rather. And I'm putting negative signs for this because essentially what I'm doing is rewriting z equals 200x1 plus 516x2 plus 274x3. I'm bringing everything to the left side of the equation so that it is equal to 0, and this is what I'm trying to maximize. So my process here is that I'm going to try to make this number down here as large as possible. And that will end up maximizing the calories burnt while still being true to the constraints. And this is going to go through several iterations, and for each iteration, basically what we want to do is we want to pick the column with the most negative number in the last row. And so for this first iteration, that's going to be right here, because negative 516 is the most negative number. Now I'm going to find a ratio between my coefficients and the number corresponding to that column. So this is 26 over 1, which is 26. This is going to be 4 over 0, which is not good, that's undefined. And this is going to be 0 over 1, which is 0. We want to have the smallest positive number, and in this case 0 counts, so I'm going to select this row that I'm going to work with, and this number 1 right here becomes what we call my pivot number. And this is what I'm going to use to, in a sense, eliminate all of the other numbers in that column, so that in my x2 column, this 1 is the only one remaining. Everything else will be gone. Okay, so we want to basically eliminate all other values in the pivot column. And to do that, what we're going to do is, if necessary, we're going to divide that pivot row by this pivot number, and then if necessary, what we'll do is we'll add or subtract multiples of the pivot row to other rows. So the beauty of this method, the simplex method, is that it gets you to an answer fairly quickly. We're only going to have to take really 3 steps to do this. Okay, so this is our first step. So to get rid of the first one right here, we're going to have to add -1 times row 3 to row 1. We don't have to do anything to the second row because that's already a 0. We're not going to touch the pivot row because we've already turned that into a 1. And now for the last row, we're going to add 516 times R3. So for each of these steps, I encourage you to either write down this previous matrix or take a quick screenshot with your phone or computer to refer back to, because I'm going to kind of quickly write down what the result is, because this is just kind of simple adding and subtracting. So in our next step, we're going to end up with, or rather have a starting matrix. If I have x1, x2, x3, all right, so we're going to start with 2, 0, 2, 1, 0, negative 1, 0, and 26. Where did all those numbers come from? Well, remember that row 2 we're not touching, so that's just as it was. But really what we did was we took row 3, which looked like this, and we subtracted row 3 from row 1. So 1 minus negative 1 turns into 2. 1 minus 1 turns into 0. 1 minus negative 1 turns into 2, and so on and so forth. The only thing we picked up that we didn't have is this 0 for slack 3 turned into a negative 1. Okay, now the big change is going to happen in the last row. I'm going to have negative 516 plus negative 200. So this will be negative 716. Then this is what we wanted to do. 516 times 1 plus negative 516 gives us 0, and that completes this column. It gets rid of all of the non-1 entries except for our pivot. That's why we call it the pivot. And then for the last one, we have negative 274 minus another 516, or negative 790. Okay? And to round out these numbers, we'll have 0, 0, 516 because of this one right here, 0, and 0. Okay, so let's talk about what we're going to do in the next step. Remember that we're trying to maximize this number, and we haven't gotten very far yet. So we're going to take this third column, because negative 790 is the most negative number, and again we're going to do our ratios. We'll take 26 divided by 2 is 13. We'll take 4 divided by 1 is 4, and we'll take 0 divided by negative 1 and get 0. Now you might think that we want to pick this 4 right here, okay? And we do. The reason that we want to pick this 4 is that this 1 right here is already set in the x2 column, so we don't want to do anything with the x2 column. And if we end up picking this 0 here, we're going to end up changing all of the entries in the x2 column. Okay, so we kind of leave this one as is. All right, so we don't have to divide by any constants because we already have a 1 for our pivot number. All we need to do is think about what we need to add or subtract to each row to eliminate the number there. So for the first row, we're going to do negative 2 times row 2. The second row is our pivot. The third row, we're simply going to add row 2. And then the fourth row, we're going to add 790 times row 2. Okay, so we'll go to our next slide and we'll write that out real quick. And of course, we have x1, x2, x3, s1, s2, s3, and we're calling this the hours. Okay, so we're going to write row 2 because we're not messing with that. That's our pivot. Okay, so that is 0, 0, 1, 0, 1, 0, 0, 4. And then we have for our first row that we're subtracting 2 times the second row. So that won't change the first two numbers, and it'll change the third number into a 0. So we'll get 2, 0, and 0, and then the rest of this will just be 1, -2, -1, 0, and 18, because that was a 26, and we subtracted 2 times 4. Just like this one right here turned into a -2 because we subtracted 2 times 1. Okay, our third row, we're actually adding our 2, and that doesn't do anything to the first two, but it turns this one, this -1 right here, into a 0, and the rest of the numbers will be 0, 1, 1, 0, and 4. Finally, in our last row, this is our big number row, we have 790 times 0 does nothing. We still have -716. Okay. We have 0 plus 0. And we eliminate our -790 here. That's the whole point. Okay. And unfortunately, as a byproduct, we get 790 here. And we previously had 516 here, and this value is 0. Now we are going to gain 790 times 4. So this number has shot up to 3,160. And remember that this is going to represent the total number of calories burned. Oh, and by the way, this Z is a 1. So that was actually a typo on this slide. First slide, we had that correct. Okay, so that shows us that when we have no other negative numbers in this row and Z is 1, our profit or calories or cost or what have you will be maximized. Okay, so now we just have one more step, and that is to get rid of this -716. So we do the same thing. We have 18 over 2 is 9. We have 4 over 0 is bad, because that's undefined. And we have 4 over -1 is -4. And because that's a negative number, we don't even think about it. This will be our pivot row. But we have to do two things here. We have to divide this row by 2. And I'll do that in a different color. So 1, 0, 0, 1/2, -1, -1/2, 0, and 9. And then we have to decide what will we do with that row to the others. So of course we'll leave this one alone. Row 2 we're not going to touch because we already have 0, 0, and 1. Okay. And row 3 and row 4 we're just going to add 1 times row 1, and then we're going to have to add 716 times row 1. All right, let me switch back to my original color here, and that's going to give us the following. Whoops. My swipe didn't work for that. Okay. And so here is going to be our final matrix. Okay, so we have x1, x2, x3, s1, s2, s3, z, and then this will be the hours. Whoops. And so we're not touching the first row, so I'm just going to write it as it was. 1, 0, 0, whoops, 1/2, -1, -1/2, 0, and 9. The second row, we're not touching. First row is technically our pivot. So we get a 4 there. Our third row, remember that we're simply adding things. So I'm going to get 0, 1, 0, 1/2, 0, 1/2, 0, 13. I'll just write that out. Whoops. And then finally, what we're going to do is add in 716 times R1. That will eliminate this one. Okay? We're adding 0, we're adding 0. We're going to have to do 716 times a half, which is 358. And positive numbers are fine. We don't care about that. Now we're going to have to take 790 and add 716 times -1, but that's okay because I still have a positive number. And then I'm going to have to do 516 plus 716 times -1/2, which turns into 158, and z is 1. And now we do 716 times 9 and add that to 3160. The result is 9604. So check out what we have here. We have a 1 right here, a 1 right here, a 1 right here. And if I switch the order of these two rows, I would have basically that diagonal that we talked about at the beginning, or that we're looking for. And this means that the solution of our problem is that x1 is going to be 9 hours, x2 is going to be 13 hours, and x3 is going to be 4 hours. Remember that what we wanted was for the jogging to be less than or equal to the swimming plus the biking. And we also wanted the swimming to be less than or equal to 4 and the total number of hours to be 26. You can see that this solution satisfies all of those things, and that means that the number of calories burned is 9,604, and since we're given that we burn 3,500 calories per pound, that means that we're going to get somewhere in the range of about 2.7 pounds per month. So this is our introduction to the Simplex method. It took a little bit of algebra and it took 3 steps, but aside from that, it's a very effective way of quickly arriving at an optimized solution. So thanks for watching, and we hope that you'll send us any other questions you have.